Hello everyone, welcome to the channel. In this video we will learn about the types of subsets, that is proper subsets, improper subsets. Also we will learn about universal set and comparable sets. We have already learnt about the subset of a set, that if there are any two non-empty sets A and B, then A is a subset of B if every element of A lies in set B. Now we'll learn about the types of subsets. The first one is proper subset. What is a proper subset? Out of these subsets, some are proper subsets, some are improper subsets. So what is a proper subset? We say that a set A is a proper subset of B if A is a subset of B but A is not equal to B. It means every element of A lies in B but every element of B does not lie in A. Both are not equal. Or we can also define it in such a way that a set A is a proper subset of set B if there is at least one such element in B which is not lying in A. For example, suppose we have a set A, in this elements are 1, 2, 4. Another set is B in which the elements are 1, 2, 3, 4, 5. We are getting here two elements are more in B. A is not equal to B. Then we say that A is a proper subset of B. And it is represented as A is a subset of B. This symbol of equal to we are not using in this. And if A is not a proper subset, then it is an improper subset. Now we learn about what is an improper subset. We say a set A is an improper subset of set B if A is a subset of B and A is equal to B. It means if the sets are equal, then they are improper subsets of each other. Or we can also say that every set is an improper subset of itself. We can also say here that if we talk about empty set, we know that empty set phi, or we represent it by empty curly bracket, is a subset of itself. What type of set it is? It is a proper subset. It is a proper subset of every set. But we have to remember one thing, that it is improper subset of itself. But phi is an improper subset of itself. It means, can we say that the number of proper subsets of a set A will be given by 2 to the power n minus 1 if A contains n elements? We know that number of subsets, total number of subsets of a set containing n elements is given by 2 to the power n. But one of them is an improper subset. It means the number of proper subsets will be given by 2 to the power n minus 1. For example, suppose we have a set A having the element AB. Here we find n is 2. There are two elements. And hence we can say number of proper subsets of A will be 2 to the power 2 minus 1, that is 3. After learning about the subsets of a set, proper subsets and improper subsets, can we say that if A is a subset of B and B is a subset of A, this implies that A is equal to B? It means to prove A is equal to B, or to prove that two sets are equal to each other, we should prove that they are subsets of each other. It means to prove A equal to B, we should prove that A is a subset of B and B is a subset of A. Now, what are comparable sets? We say any two sets A and B are comparable if either A is a subset of B or B is a subset of A. For example, suppose we have a set A having the elements A, B, C, and B is another set having the elements A, B, C, D, E. Then we know that A is a subset of B and that is proper subset. It means both A and B are comparable sets. It implies that A and B are comparable sets. Now we discuss about a universal set. What is a universal set? Any set if we have such that it is the superset of all given sets. Or we can say that if we are given some sets and we find a set whose all these sets are subsets, then we call it a universal set. So we say a set whose all given sets are subsets is universal set. It is represented by capital U. For example, suppose we have a set A having the elements 1, 2, 4. Another set B in which the elements are 4, 5, 7. And we have one more set C in which the elements are 1, 2, 6. Then a set U containing all these elements at least, maybe more than that. Suppose we have 1, 2, 3, 4, 5, 6, 7, 8. We can take more elements also. So do we find that U is a superset of all these sets? Or we say that A is a subset of U, B is a subset of U, and C is also a subset of U, and then we can say that U is the universal set of these all. We can take one more example. Suppose we have been given a set P and that is X such that X is an isosceles triangle. And we have been asked to find its universal set. Then we can define that universal set U for this will be X such that X is a triangle. Because this P here is the subset of U. All the triangles contain all the isosceles triangles also. In the next video, we will learn about the Venn diagrams. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.